Welcome to the Future Space and Polish Space Agency podcast. Future Space is a European Union Erasmus Plus funded project for astronomy and space exploration in educational systems. We aspire to provide a catalyst for change in understanding and teaching science, technology, engineering and math in upper secondary schools in Poland, Greece and in the Netherlands. Sit back and enjoy our podcast.
Ladies and gentlemen, everybody hiding over there behind their web browsers. It's me, Paweł Uszyński from Warsaw, Poland. I am your host for the second episode of our mini podcast series for Polsa, Polish Space Agency, Polska Agencja Kosmiczna. And today we are hosting three people. First, let's welcome Polish branch of this meeting, Klaudia Bielińska and Sylwia Nasiłowska from CloudFerro.
Good morning. Hi.
Hi. Hello.
Hi. Hello, ladies. So, could you, Klaudia, introduce yourself and your company, maybe?
Yes, of course. Thank you very much for this invitation. We are really happy to join this podcast. Klaudia Bielińska, I'm representing CloudFerro company. At CloudFerro, I'm Earth Observation Product Manager. What is actually CloudFerro? What do we do? CloudFerro company is a Polish private company. We are mainly present in the space sector. What do? We provide cloud computing services. And also we provide, let's say, awesome cloud repository of Earth observation data. Whenever you are in a need of satellite data, you should check our Klaudia's platform. This is a huge repository of the data coming from Copernicus scientific program. Basically, these data are from Sentinel satellites, and also we provide very high resolution satellites.
Yeah, and I have to tell you, sorry, just to interrupt you, I know that you're collecting so much data that these are actually like thousands of laptop equivalents per week. I saw it on YouTube. That's correct.
Yes. So I think that now in our data repository, we have over 21 petabytes of data stored. So this is really huge repository. And thanks to our cloud services, we have our cloud, let's say, servers in 7 locations around Europe. So in Poland, Germany, and UK. So we keep our data there. So this is a huge storage. And also we provide cloud computing services. So if you need to process your data in a really quick and efficient way, cloud services are for this.
Okay. Great, thank you. And Sylwia?
Hi, my name is Sylwia Nasiłowska. Here at CloudFerro, I am project manager. From the education field, I am a PhD of Earth Science. I am a geographer. My background is geography, but I finished the specialization of geoinformatics and remote sensing. And during my whole work career, I was working with the applications of satellite data, and I was finding the solution for various environmental problems. So here in CloudFerro, I'm also involved in analyzing and finding the solutions for various issues on our Earth, like, for example, Earth, soils, or forests. So I'm in general a remote sensing specialist, and I'm managing this project related to this type of problems.
You mentioned remote sensing. This sounds kind of weird even to me, I would say. I'm going to ask you in a minute about remote sensing, but first, let's welcome Jos de Laat from Netherlands.
Yes, thank you, Paweł. My name is Jos de Laat. I am a scientist at the Royal Netherlands Meteorological Institute. So we are responsible for all kinds of weather forecasts and weather information in the Netherlands. I've studied actually meteorology at university and also did a PhD at a Dutch university. And then after that PhD, I was offered a job as a scientist in remote sensing. of the Earth's atmosphere, and I have been working on remote sensing ever since for the past 20 years. I do many things, but mostly scientific research and interpretation and the understanding of what those satellites are observing, what they are measuring. And I work on a variety of topics like the ozone layer and air pollution, greenhouse gases, but also on weather, obviously. And more recently, I've also started to focus on actually finding useful remote sensing data for use outside of the traditional research domain, so outside of academia and institutes like my own institute, looking for applications like making aviation safer, or specifically looking for companies who emit a lot of air pollution, and if there are international agreements to make sure that companies stick to whatever they promised to do, actually. And then we are looking for companies outside of research.
Yeah, so it's not only Earth observation, but it's some kind of climate sciences.
Yes.
Am I correct? What you do?
Also.
Okay, let's start with yours now. You introduced yourself as the last one. Let's ask you a first question, because this remote sensing thing, it sounds like you were able, to smell something like in huge distances, like it's senses, right? Senses, hearing, smelling, touching.
Yeah, so it is what it literally is. Sensing is like measuring, and remote simply means from a distance. And for a long time, people have used satellites they put them in orbit in space, and they use them to look at the Earth and to measure all kinds of things. It is in a way not different from your typical telescope on the ground looking at stars, but then rather than looking at the ground to the stars, you put an instrument in space and look back at the Earth.
Okay, I get it. So it's not like literally smelling things, but can you, for example, collect some chemical data so it's kind of smelling the atmosphere? Yeah,
we can do that, but in a different way than you normally would do when you smell something with your nose.
Yes, of course. So you have digital noses full of technologies for that. So let's assume now that Jos collected some great data and you're gonna store it on your massive servers, Klaudia and Sylvia. Maybe let's go with Sylvia. Now, I'll ask you this question. If we collect any remote sensing, any other data that creates any kind of this, like it's online map, so we know all the online maps of Earth, so it's like an online multi-layered, multi-sensory online map. Why is it important? What can we do with that data? What are our benefits?
Yes, we have really a huge amount of benefits from satellite data, because we are sensing not only visible light, which we are sensing with our eyes, we are sensing different wavelengths. So we are sensing in near infrared, we are sensing in maybe in active wave, but in microwaves. So we see more. These whole layers in our data means something different that we can see with our eyes. So for example, with the near infrared, we can see different states of vegetations. For our eye, it is only green, but with near infrared, it can be really diversificate this response from the leaves. So we, thanks to these various and enormous amount of data in different wavelengths and in different sensing modes, we can acquire really much more information that it is for normal people available.
So it's like you can store information about the light that we cannot see with our eyes.
Yes.
And that light has got some impact on our planet, simply.
Maybe in different way. The Earth elements, the elements of Earth's surface, have different response to the various type of wavelength.
Yeah.
So it looks different in, I think, in 1000 micrometers and different in 1 1,500.
Yeah.
So this is the difference, because each object has his unique spectral signature.
Mm-hmm.
And thanks of that, we can recognize and we can analyze changes and the properties of these objects.
Okay, I get it. Klaudia, because Sylwia said you can collect and use data about light. Can you store and use other types of data when observing Earth?
Well, actually, any data you want. Because we have different, let's say, levels of measuring.
Mm-hmm.
So we measure from space, we can measure things from ground, from unnamed vehicles. So everything what you measure can be stored and can be processed.
Okay, but I understand it all somehow, not in details.
Yes.
But let's say there's a guy like me somewhere who has no chance to talk to you, and he never will. He will never listen to our podcast even, maybe, which is unlikely, but let's assume. And what are going to be the benefits for just people living there, not even knowing that your scientists exist? What are the benefits, like, in our everyday lives, I would even ask?
Okay. So with the satellite data, with any data you collect, you can apply those data to really everyday usage. So, for example, we can speak about environment monitoring, agriculture monitoring, natural disasters activities, special planning. Actually, there is a plenty. So you can just think of anything, and then the satellite data, for example, can be used for it.
Yeah. Because
that's what actually Sylwia said, that the light, actually the spectrum, is very important here, because we collect the data, and the data are divided into single bands, into single channels. And then when we take all of the bands together and the software to process the data, we can take out from this data very important informations.
Okay.
Let's think of any example. Let's, for example, think of floodings. So from space, you can see the extent of the flood. So when the rivers comes out from the river embankments, you just probably, if you go into the field, you just see it from the ground, right? On the ground. But from the space, you can see the whole extent. And then you can plan some activities. You can react on this situation.
So Earth observation can, for example, make me safer, can make me less hungry because my food that grows
of course,
is going to be more efficient, for example. So actually, from what you say, it's pretty much everything. So in any area of life, I can simply ask myself, what Earth observation can do for me?
That's right.
I'm not asking this question every day. Maybe I should start. Anyway, Jos, maybe I'm going to ask you this question. If you're anyhow into it, because I know from Sławek, of course, that Europe has got its own program of observing Earth from space, and it's called Copernicus. Can you tell us anything about Copernicus? Are you the good address for this question?
Yes,
you are. Great.
Yes, I am. So Copernicus is a unique program to observe Earth from space. So all European countries together, or almost all European countries, cooperate together in space agencies like ESA, the European Space Agency. And for weather, actually there's also a dedicated organization called EUMETSAT, the European Meteorological Satellite Organization. And we have been cooperating for 50 years on this sort of. And after, let's say, trying to see what kind of technologies are available and how does this actually work and how can we measure, about 20 years ago, we really started to put a lot of instruments in space and trying to really do innovative things. And that worked very well. You have to keep in mind that a typical satellite is built to last for, let's say, 5 to 7 years. Space is a very harsh environment. Things break down quickly. So Europe came up with an idea that we're just going to plan ahead for 20 to 30 years ahead in time.
Oh, wow.
Similar missions every couple of years or so, which is good news also for me because at the moment satellites are planned up to, let's say, 20 years from now, and that means that I probably have a job until I retire.
Yeah, that's going to keep you busy.
But you have to, it is going to keep me busy. But you have to keep in mind that a program like this. So that's a great space program that we have set up in Europe. Very clever.
This is the Future Space Podcast.
Great. Probably it's not only serving Europe, but somehow the data you collect is relevant to the whole planet and other countries, right?
Yes.
Yeah, and well, it's cool that it's named after Copernicus. We're still in the country of Copernicus here, at least me, Klaudia, and Sylvia. Sylvia, maybe you can tell me, is CloudFerro also somehow involved into Copernicus? Just having in mind that you have so much valuable data, do you share this with Copernicus?
Yes, of course. We get the data from Copernicus and we are sharing it with the people. So it is worth to mention that all data from Copernicus program is available for everybody for free, even for commercial purposes. So our DIAS, CryoDIAS, is for sharing this data to make them easy to access. So using a CloudFerro platform, everybody can log in and access them and use as...
You're serious?
Yes, of course. For free.
I'm going to do it right now.
Of course.
I'm going to do it right now because these are my remote senses you have there. Like, you know what I mean, that all that remote sensing. Will I understand anything? Because it's science. Will I understand anything?
It is really easy to understand because we have something like CryoDIAS browser, and then you can really easily choose the whatever region on the world, on the globe you want.
Yes.
And play with various bands, with various wavelengths, and see various remote sensing indices. So you can really touch this remote sensing power with our CryoDIAS browser. And for more advanced users, we have Finder and Dashboard, where you can log in and when you can compute all this data.
Mm-hmm. What's the address of your browser? Can you repeat this for me?
CryoDIAS. EU at the end. That EU.
CryoDIAS EU. I'm just there. Okay, it's a podcast, so I'm not going to describe the website, but I had to take a look. CryoDIAS.eu. And I'm here and I'm going to create an account and I'm going to lose the rest of the day. No, I'm not going to lose. I'm going to invest the rest of my day browsing through it.
But even without login, you can check tools and then EO browser. And then I
will leave you my login because I need to get subscribed to your newsletter that you probably have there.
Yes, of course.
So if there's any chance of a flood, for example, I'm going to be the first to know. Anyway, I ask a question, what can Earth observation data do for you? It can save your life. So, hey, people out there, see some data on the web page. I'm going to give you the address and probably we're going to drop you a link to this CryoDIAS.eu Copernicus website. You're going to get some Earth observation data for yourself. And that's going to somehow maybe not change your life, but it's going to make your life safer and easier, I hope. So take a look, guys. And let me ask something else. And maybe that one's going to go also to Klaudia. What is upstream and downstream segment? That's the question. Can you help me with that?
Well, actually, we keep talking about this subject. Even yesterday at the company, we had a conversation about it. Because what do we do in the space sector? Companies, organizations, and so on, they are divided. Their work is divided into downstream and upstream. So upstream is simply what goes up to the space. And downstream...
Sending things into space. This is upstream.
Yes, that's right.
It's uploading.
Yes, that's right. So actually,
and downstream is downloading the data.
Yes. So everything which goes out, so satellites, specific devices, optical devices which are on board on satellites, specific instruments which measures some things up in the air and so on. And the downstream is everything what goes down to Earth. So let's say that satellite imagery, which goes down from the satellites, and then the applications of the satellite imagery are in the downstream segment.
Okay, I get it. So yeah, it makes complete sense. How many satellites of different kinds, and you can even give me the kinds of satellites, what their senses are. How many satellites do we have around Earth right now flying? I would guess, let me make a guess. Okay, I'm going to make a guess.
Okay.
I think it's around 600 or 700 satellites.
It's more.
It's more?
Yes, it's more. It's actually a hard question because we have satellites from different satellite providers, from different space agencies. We have big satellites. We have small nanosatellites. And
what are nanosatellites?
Nanosatellites are really small satellites.
What do you mean by saying small? After like a mug of coffee, for example?
I think bigger a bit. But the difference between satellites is in their weight. So they are more heavy or light. Mm-hmm. So, for example, there are startups which are into building small nanosatellites.
Okay, but still, I'm sorry.
Yes.
Is nanosatellite like a chair, like a desk? Sorry, but I need to know this. What size is nano for satellites?
Microwave, maybe.
Microwave.
It's up to 10 kilograms.
Up to 10 kilograms.
It's from 1 kilogram up to 10 kilograms.
Okay, but you don't send microwaves into space. It's not like literal, okay? All right.
Yeah, but you can imagine that, for example, you're buying a bag of sugar, a bag of flour, and it's like a nanosatellite. So 1 kilo, even 1 kilogram. Yeah.
I have a speaker there that's exactly 10 kilograms, 10.2, I think. But I'm not going to send it to space. I like it too much to send it into space.
Okay. Yes. Mm-hmm. So they are much cheaper. To produce that kind of nanosatellite, it's much cheaper than produce the big one. So that's what we see on the market.
Yeah. And we have some nice microchips. All the computers are really miniaturized, like everything's very small, so it's efficient probably. But yes. Is there any estimation? Because I said, okay, 600. Is it 6,000? Should we count them in thousands?
Yeah, and it is 3,000 or 6,000 depending on the source.
Yes.
Okay, wow. I mean, when I think about it, it's an endless, what you do is an endless source of imagination, fun, and also great prospects for our lives and for our planets. And this is really, really fascinating, all this. And maybe I should ask you, because probably you have to be fascinated somehow with space to do what you do. And what's the most beautiful, passionate thing you find in your work? What about you, Jos?
So what is really nice and interesting is that this is technology, but it's high tech. You know, it's really like very innovative. You're doing things that no one has done before. You can look at things and events and systems that no one has ever looked before with such detail or in various new ways. So that's really nice. It's really about discovery and discovering new things. That's always very enjoyable. It's also relevant, as Klaudia and Sylvia already mentioned. We are now in a better position than ever to see what is going on in the world. So we can check things, we can see if things are going wrong, also in places which may be very difficult to reach. But it's also that this is a very international world. So if you work in this field, you have a real chance to talk to and meet people from all kinds of countries in the world, which I personally very much enjoy. And hopefully at some point also meet people in person again, go places and experience other cultures. I mean, that is a fun part of the job as well for me. Yeah, and finally, one thing is that we talked about how much data there is. There's so much data now, and this is still growing, and it will get even more and more. So we also need new young scientists starting to work on this data.
Exactly.
Young people who understand technology, who have some fun in working with data and working with numbers.
And exactly that's, yeah.
Really need them, and there are great opportunities.
Yeah, and that's actually what I wanted to say, that you don't only sit there watching our planet from above, but you travel a lot, for example, from what you said.
Yeah, so you can travel. There are many meetings, all kinds of topics around the world.
Yeah, it's very international.
Present your work. It's very international.
Okay. Great. So all the young people out there, listen to me now. If you feel like that this is the career for you, I'm telling you, go for it. Because if I was a little bit younger, I'm not going to tell you my age. I'm not too old, but definitely I'm too old to start a new career. And if you're not too old to start a new career, think about any career in space sciences, and probably, maybe one day, in space itself, because we are getting closer somehow. Maybe that's going to be another question. Sylvia, what's the most beautiful, passionate thing you find in your work?
Okay, so what is the most passionate and beautiful? I have never think about my work with that adjectives, but yes, it is really interesting, and I'm really curious about applications of Earth observation data, because you can do really a lot of things with just simple images registered in various wavelengths. You can really see really more things, more detailed, and you can observe things which are not even possible from the ground. So this gives you better perspective, different perspective, and totally different possibilities. And for example, we can detect diseases, we can detect some chemistry in our air. So this is nothing easy from the ground. And it is really interesting to find out still new applications. So all the time during my job, I'm finding about new applications, and I'm really discovering that they are still more and more advanced and more interesting. The most important that there is the thing that they are useful and they really can change something. Then they really can influence our life and our environment. And this is really added value, huge added value for people.
This is the Future Space Podcast.
Yeah, and taking care of the planet. Like, yeah, I like that. If you ask me what I like most about your work, that you take care of the planet somehow, and we really need this. I think we can agree on that. And Klaudia, what about you? What would you say? What do you like most about what you do?
Yes, I think that first of all, it's important that I like my job. So I think that sometimes it happens that you do something but you hate it. So I think that it's really great if you like what you do. So when I say to someone that I work in the space sector, they think that I'm building satellites and then, just some devices which goes up into space. But me and Sylvia, I think that we are most of the time looking on the ground from the satellite levels. So all of the imagery which is taken, which is acquired by the satellites, we are looking at the imagery and we are trying to discover different things, different processes on the ground. So like Sylvia said, detecting different things.
Remote sensing.
So this is really, yes, that's right. That's what we do. So this is really nice and important thing which we do. We talk with our customers. We share our knowledge with customers. And sometimes, let's say we are opening their eyes because don't, for example, believe that in, for example, agricultural applications, they can use the data from space to see if their plants are growing and in what stadiums are their plants and if there are any diseases in their plants. So with the satellite data, we can see if, for example, the level of water in the plant or in the...
If my grandma is sick.
Not grandma, but the plant. Mostly, yes.
Okay, so
yes.
It's like globally visible. No, I mean, seriously, you can detect that.
Yes, we can detect.
Wow.
And we can predict how it will grow, how it will develop in coming, for example, months. So it's really nice thing. But we see that, let's say that groups of our users now, they are more aware of what they can do with the satellite data. But I think that years ago, they were not so sure that they can use the satellite data in their everyday applications, in their work, in their projects. So what I like in my job, I like to talk with people and I like to tell them about space, satellites, about data. They can use the platforms, they can use cloud processing and so on. So I talk with students also at universities. We promote space and space applications and remote sensing, of course. So sharing knowledge is very, very important thing for me, and this is what I like.
And let's stick to you, Jos. We're probably somehow closer and closer because we talk about collecting data, we talk about remote sensing things, but we're getting closer to going to space in person. Like it's gonna be available, probably not for everybody, but like, for example, commercial flights or business flights, scientific flights in person. Maybe one day, do you think we're gonna have some commercial flights like in our lifetimes available?
Well, in a way, they already are starting this. There are some companies actually that offer the possibility to and what they then call fly to the edge of space. So you will not fly to the moon, but you can sort of get a
You're going to leave the atmosphere.
Yeah, you sort of go to I think at the moment 200 kilometers.
But it's so. Marketing
and
for now. It's just
a few minutes
marketing.
Of gravity free.
Yeah.
But there are companies looking into this. The problem is I'm not that much in favor of it. Because it means that if this really becomes feasible, that many people are going to fly into the upper parts of the atmosphere, and because you need rockets for that, you're going to inject all kinds of exhaust fumes into the atmosphere.
Okay.
So that's my personal view on this.
But it's a valid point. You're an expert. You simply predict what might happen, right?
Actually, some very useful research actually started with governments wondering, well, if we're going to fly higher up in the atmosphere, what might the impact be on the atmosphere? This was like 50 years ago. That was a real starting point for a lot of new research to be developed. So it is a valid question. It has been for a long time. But I'm not sure if anyone can prevent companies doing this. We just can ask them to consider it very carefully. And unless we think it's a real big threat, it may be difficult to avoid. Probably
we can make some regulations not to make it too wild.
Yeah, maybe.
Right? Okay, Klaudia, that's gonna be a very straight question. Would you like to go to space? Because you have all the satellites and your remote sensing. But what about changing it to direct sensing? Like you go to space. Would you like to go to space yourself?
Yes, of course, I would like to. From time to time, I'm looking at the pictures sent by International Space Station. So they are really impressive. So it would be nice to be there and to look at the Earth from different angle and live, not to look at the pictures, but to see it from above.
Yeah.
It will be a nice experience.
Yeah, but there are probably not like too many people so far that visited space. Do you know how many people in history went to space? Around like estimation?
I think the number is 569 to be precise.
506. So I thought it's around 100 people, but if it's 500, your chances that you're gonna go to space are rising, like somehow relatively, of course. But okay, but still, I believe that if you're into space science, probably in the future, we're going to see more and more people going into space for their work. It's going to be a little bit more accessible, I suppose, somehow, right? Am I right?
Maybe yes. Yes, I think.
Yeah, so I wish I was 20 years younger to start something new. Okay. The last thing for today, guys, because this is so fruitful. Really, I enjoy this. I hope you enjoy it too. And I leave this meeting really smarter for myself. And you made my life improve somehow. It's for real. I mean it. And just remembering what Jos said, that we have, I'm going to ask it to you, Jos, that we need the young scientists, that it's a great prospect for having a great and meaningful life, an interesting one, and having a warranty of being hired for many, many years because there are so many satellites to be sent. Somebody has to take care and downstream all the data. What would you say to young people? Hey, all the youngsters, listen up now. Jos is going to tell you why should you go into space sciences. What would you say to a young person?
What would I say to young people looking at their future? I think it's, as I explained, it is a great area to be involved in right now. It's high tech, it's interesting, it's highly relevant, it's very broad. There are many satellites, lots of data, and who doesn't want to tell on a when they're out in the weekend, like, hey, I work for a space agency. That sounds like something really interesting. If nothing else, then that's something for a conversation.
Yes, you're going to impress your colleagues and your female colleagues or some male colleagues that they are interested in you, which is an important factor also in your life.
Definitely. Yeah, but also remember that we live in a technological world. So anything that you will learn, you can use it elsewhere as well. Many of the things, the techniques, the skills that you learn, you can use in many other businesses as well. So it's a very useful way also to start your career.
Okay, great. Sylwia, what about you? What would you say to a person who's thinking, well, Wayne, maybe I should go into space science?
I will tell him to be brave and to be more open to this, because whatever the strongest things, whatever your advantages, whatever is your character, you can find something for yourself. You can be a lawyer, you can be a geographer as me, you can be IT specialist or business development. You can find the place for yourself, because this is really huge market and it is very developing market. So there will be a job. There will be very prestigious job.
There will be jobs in space.
Yeah, international. So you will meet people from all around the world, and you will be very happy about things you will do, because this will be something meaningful.
Yeah, so whenever you feel like being a lawyer, a doctor, a physicist, an observer of things, an IT guy, think about bringing it to space, because it's all starting being really, really possible. Great, this is really great to hear. And Klaudia, I'm 20 years younger, and I ask you, why should I go into space science?
Okay, so maybe at this point I would like to quote one of the professors from university, Dr. Bogdan Zagajewski, who told me a couple of years ago that remote sensing is a fun thing to do. So this is an important thing, that really, just discovering things at the images, detecting things, and just simply getting things from images. It's a really nice thing to do. But maybe I would like to highlight one important thing, that we need more women in space sector and in technology, because we see that there are many guys working at IT sector and space sector, and girls are not so brave. So we want to encourage girls to go into the space sector and to do scientific things. We need more girls. And as Sylwia said, it doesn't mean that if you work for a space sector, it doesn't mean that you will be only a scientist or you will just build satellites. For example, I graduated remote sensing, geographical information systems. I worked in a scientific organizations, but I worked also at the commercial companies. So I went through the path which I could choose, whether working in the science or whether working in a commercial sector. So it's a nice thing to do. You can do many things, and this is a wide area actually for you to choose what you would like to do.
Mm-hmm.
And of course, interesting work, challenging work, but I'm sure you will be happy of what you've chosen, and this is important.
What you said about the girls, I mean, no. You said the girls are less brave. I don't believe that. I'm not a girl, but I don't believe that girls are not that brave. The model of our lives and our culture says sometimes that the girls are not brave. Well, I know many girls that are braver than me, that's for sure, and would totally make it in the space. I'm sure of it completely. So, hey, all the girls, space needs you as well. And guys, I think that's it for now. I would talk to you for hours and hours and hours. I leave this podcast smarter. I hope all our listeners feel the same about it. Thanks for being with us here. Thanks for having me as your host. I wish you all the best in your space explorations of every kind. And I hope to maybe meet you one day in person so I can take a look at your fast data and multi-resolution maps of all kinds.
Of course. Thank you very much. Thank you.
Thank you.
Thank you very much also, and we're happy to meet you and talk with you. That was great.
This is the Future Space Podcast.